Bonsuelo, mathletes. We're going to put it all together today. Last couple lessons has all been preliminary stuff to graphing polynomials. Today we're actually going to graph them. Actually, we're not going to make a great graph. I'm not going to label the axis and make sure everything's accurate. But basically, we're just going to make a good sketch. And what does that consist of? Two things. Number one, the extremes. And number two, the intercepts. That's what I've been talking about for 2 or 3 videos here. So let's get to it. Okay, first of all, number one here, since the leading coefficient's positive, then the right is going to go up. Since the degree is odd, the left is going to do the opposite of that. Okay, so we know for sure it's at least going to pass through the x-axis once. It may pass through it 3 times. We're not really sure at this point. But it's going to have 3 sections to the graph. Okay, so let's find the y-intercept. And if we plug in 0 for all the x's, we get -3. Okay, to find the x-intercept, we plug in 0 for y, and then we factor it. And I'm not going to go through all the factoring in a lot of great detail here, but we're going to factor out an x squared, which gives us x plus 3. We're going to factor it, because you should already know how to factor these. I'm just showing you how to apply it. Then we factor out a negative, and that gives us x plus 3 is the greatest common factor, and then x squared minus 1. So we have x plus 3, and then factoring the x squared minus 1, we have x minus 1 and x plus 1. Okay, so what does that mean the x-intercepts are? -3, 0, 1, 0, and -1, 0. So I'm just going to put those generally where they be. Again, I'm not going to label the axis real accurately here. Okay, the y-intercept is 0, -3, which is down here someplace, down here on the bottom someplace. The, down at -3. The x-intercept, one of them is at -3, one of them is at -1, and then one of them's at 1. So again, remember, I'm going to kind of erase the original arrows I had drawn here, and then I'm just going to draw the sketch. So it goes up, down, through the y-axis at -3, and then like that. So it's got the x-intercepts of -3, 1, and -1, and the y-intercept at -3. Okay, that's basically going to be it. I mean, now it's just a matter of taking a look at examples. Okay, so again, your leading coefficient here is positive, so it's going to go up on the right, and it's cubed, so it's odd, so it's going to do the opposite. It's going to go down on the left. Okay, so let's find the y-intercept, and if you plug in 0 for x, you get 0, so the y-intercept 0, 0. To find the x-intercept, okay, first of all, you take out the greatest common factor, which is x, leaving us with x squared minus 4x plus 4. And then we factor this, sorry, that should be equal to 0. I apologize. And then we factor this into x minus 2 quantity squared. Or you can put x minus 2 times x minus 2. It doesn't matter. I put it squared for a reason. Okay, so what are our x values? This one gives us 0, so that's 0, 0. And this gives us 2, 0, but with a multiplicity of 2. Okay, well, what does that mean? That means at 2, it's just going to come down and touch the graph. It's not going to pass through it. And if you think about it, look at what would happen if you tried to do that. Okay, you'd say it passes through 0, 0, and 2, 0. And then the y-intercept is also 0, 0. If I tried to do this, so don't write this because this is not how it works. If I tried to do this, come down, because remember, It's going up on the right. And then pass through. Okay, well, remember on the left, it's got to go down, but there are no more intercepts. So how do you get this to go down and not pass through the x-axis? Again, you can't do it. So for that reason, what you've got to do is just come down and touch it, not pass through it, and then go back up and then down. So again, it's got 3 sections. It's got 2 x-intercepts, but this one right here has a multiplicity of 2. Okay? So that's why it comes down and just touches it. Why doesn't it just touch it at 0, 0? Because 0, 0 doesn't have a multiplicity of 2. It only has a multiplicity of 1. Okay, let's take a look at this one, number 3. Okay, it's got a negative leading coefficient, so it's going down on the right. And since it's to the 4th power, it's an even power, it's going to go down on the left also. Okay, so let's find the y-intercept. Okay, for the y-intercept, I stick in 0 for x, and I get 0, negative 16. For the x-intercept, I stick 0 in for y. And the first thing you should do here, and you can only do this because it's equal to 0. Okay? If it's equal to y, you can't do this. Is get rid of the negative leading coefficient. All right? It'll just be easier to factor. So if I multiply by a negative both sides, you get x to the 4th minus 8x squared plus 16. Okay, so what's that become? That becomes x squared times x squared, and then minus 4 and minus 4. And then each of those factors into x minus 2 and x plus 2. Again, at the beginning of this chapter, I said you should review factoring. All this factoring is very straightforward. There's nothing unusual about it. Okay? So what does that mean? I have 2 comma 0 with a multiplicity of 2 and negative 2 comma 0 with a multiplicity of 2. Why? Because x minus 2 exists twice, so it has a multiplicity of 2, and x plus 2 exists twice, so that has a multiplicity of 2. Now, if I was to label this properly, I would have to go down all the way to 0, negative 16, which is the y-intercept. So I'm not going to label the axis. All I know is I have some point out here, some point out here, and some point way down here. Okay? So what happens? I'm coming up from the bottom, and since it has a multiplicity of 2, it's going to turn around right there. Then it's going to go through the y-intercept. And since this also has a multiplicity of 2, it's going to turn around right there. So it looks this is a sketch. It's not like, obviously, I haven't gone all the way down to negative 16, but that gives you an idea. Okay, here, it's negative, again, so it goes down. And then it's to the 4th power, so it also goes down. All right, the y-intercept. Again, if you plug in 0, you get 0 again. It's not always true. You just have to take each problem as whatever it is. Okay. And then for the x-intercept, I'm going to set 0 in for y. And yeah, you can divide out a negative, which I'm going to do, but I'm going to divide out a negative 2. Remember, you can divide away a numerical greatest common factor, just not a variable one. So I'm going to divide everything by negative 2 and get x to the 4th minus 4x squared. Okay, now I want to take out the greatest common factor, which is x squared. And that gives me x squared minus 4. Now here, x squared, you can leave it x squared, but just realize this is x times x. So that's going to give me a multiplicity of 2. And then this is x minus 2 and x plus 2. So what are our x-intercepts? 0, 0, which has a multiplicity of 2, then 2, 0, and negative 2, 0. Okay, so let's sketch that. So we've got 0, 0, 2, 0, somewhere out here, negative 2, 0, and the y-intercept is also 0, 0. So what happens? There is no multiplicity of 2 at either the 2, 0 here or the negative 2, 0. The multiplicity of 2 is at the origin, is at 0, 0. Okay, so what's going to happen? It's going to come up, actually pass through the axis, and now double 0, double root, double x-intercept, so it's just going to touch at 0, 0, and then go back down. Again, if it's got a multiplicity of 2, it's just going to touch the axis. Okay. Here, we've got, well, what's the degree here? The degree here is 3 because this is x squared and this is x. If I multiplied all that out, I'd have x to the third power. So it's positive, leading coefficient. In other words, leading term here is 5x cubed. It's positive, so it goes up on the right. It's cubed, so it's going to go down on the left. By the way, I don't want to mislead you. It's not like all the cubes go up on the right and down on the left. That just happens to be the example they have. And it's not like all the fourths go down on both sides, okay? If the leading coefficient is positive, the right goes up. If the leading coefficient is the right goes down. If the degree is odd, the left does the opposite of the right. And if the degree is even, the left does the same thing as the right. Okay, so what's happening here? So this is going to be the y-intercept. If we plug in 0 for x, you'll find out it all goes away, so it's 0, 0. Well, you get 0, it doesn't really go away, but, you know, go ahead, plug in 0, and you should see that it gives you 0. Okay, for the x-intercept, well, it's already partially factored, so we have 0 equals 5x, and then we'll factor the x minus 2 times x plus 2. Okay, so what does this give us? This gives us 0, 0. This gives us 2, 0. This gives us negative 2, 0. So we have 0, 0, 2, 0, and negative 2, 0. Okay, so let's draw it now. Comes down, goes through it, and then back down like that. Okay, last problem. And I realize I'm going through these pretty quickly, but, you know, I spent a lot of time on the preliminary stuff, so that's really where the difficulty is. So if you haven't gotten the preliminary stuff down, this isn't going to make any sense. Okay, for the y-intercept, well, sorry, this would be what? First of all, this would give me an x squared if I multiplied it out. And then if I multiplied that, that would give me x cubed. So if you multiply this out, you'd end up with an x cubed. Okay, so the leading coefficient's negative, so the right goes down. The degree is odd because it's cubed. So that's going to go in the opposite direction. Okay, there's nothing to factor here. For your y-intercepts, you plug in 0 for x. You can actually plug it in if you want to, but it should be pretty obvious. If you plug in 0 for x, you're going to get 0. And for the x-intercept, it's already factored for you. So the negative 3x gives you 0, so that's 0, 0. And the x minus 4 gives you 4, 0. But that 4, 0 has a multiplicity of 2 because it's squared. So this square means that has a multiplicity of 2 because there are 2 x minus 4s. Okay? All right. So let's take a look at it. We've got 0, 0. We've got 4, 0. And at this one right here, at the 4, 0, right there, you're going to have a multiplicity of 2. Okay, so I'm going to get rid of the ones I had drawn originally. So we're going to come up from the bottom. Since it's multiplicity 2, we're going to turn around and not pass through the axis. And then we're going to turn and go back up. Okay? So I hope that helps. That's really all there is to it. It's like I say, if you've taken the time to carefully study the preliminary information, this should be pretty straightforward. Again, you're just making a sketch. This isn't perfect. We're not labeling the axes for the most part. I did on the first couple, but I hope that helps. Have a good day, everybody.